Thank you for the survey today. Please note that the footage could be out of position, out of alignment. Sorry about that. I've just put it together in rough format. What I'm going to do is pull together pieces, add it to surveys from other properties so you can see your property in the context of other properties, and likewise the data loggers. Please send me the data, not this coming weekend, but next weekend, and I will then pull them all together. Note that some of the conclusions evolve as the survey goes along. Have a listen to the survey now. What I'm doing now is I'm calibrating them, so I'm putting them in the same environment. They're reasonably accurate, but you'll find that there can be some variation in the humidity sensor, right. So potentially 5% above or below, and right. So I put them in the same environment. I'm going to put a pre-calibrated meter next to them, and then we'll adjust if necessary. Right. So, funnily enough, but where you have mould, you have excess vapour by definition. Right. Whether it's localized excess vapour or general excess vapour, we'll have a look into that. But typically, where you've got in more than one place, it's going to be from general excess vapour. Right. And if you've lived here for 41 years, something must have changed in the last 5 years or so for it to start to
I've really been thinking about that, and I can't think of anything that we have altered in that time that would have. We had this side of the house pointed.
Yeah, that wouldn't do it.
No, a few years ago. Apart from that, I can't think of.
So the sort of things that can change. Obviously, lifestyle can change, and since COVID, there's been a lot more staying at home, working from home. But if you're retired, you're probably not. You may be spending a bit more time here, but
I'm not.
The things like double glazing can change.
Haven't changed
That's in place, but that's old. So grandchildren?
No, don't have any grandchildren.
No. Heating regime. Because of the increase in the heating costs, the government was putting in what I consider to be misinformation, and that is telling people to heat one room, the room you're in, and turn off the heat in other rooms.
No, my wife feels cold, and so we haven't cut back on heating at all.
Draft proofing, reducing the draft. Dampness in itself a damp wall is a poor insulator, and if a wall becomes damp, a damp wall takes 6 to 9 months to dry out. Right. So if it becomes damp in winter through condensation, it may never have time to dry out, and therefore you can get that increased level of heat loss that then becomes self-fulfilling and self-perpetuating.
Right. And of course, the one thing that's different about those two rooms is neither room has got any heat in them.
Okay, but that's always been the case.
That's always been the case.
And the one thing to be aware of is that you were talking about tin cans in the pantry, and anything that is absorbing heat, tin will absorb heat, but then it will retain. It will absorb heat, but also coldness as well, and it will retain that. So one of the properties I went to yesterday, they had a lot of bottles along the side of the wall where they were getting damp issues, right. And that it stops the heat from escape. It stops the heat from getting into the wall, and it creates this sort of band of coldness for some time. Lots of tin cans. Obviously that's what you normally have in a pantry.
Sorry, there's one other thing I should explain. If you just look at this here. This was the doorway into this room.
Sorry.
When we had the kitchen done some 20 years ago, and we decided to block up that doorway so that we could use this space better, of course, and then open up that doorway. But again, that was done 20 years ago.
What it will mean is that that's going to be poorly insulated. So this is going to get the heat loss or the temperature in the cupboard
Right.
on the outside. And so a very simple solution is to put insulation on there, and I'll show you some examples.
Right.
So this shows the areas of heat loss, and you can see this particular area of heat loss just at the bottom, showing 13 degrees centigrade compared to an ambient temperature of 17, 18. So that's about a 4 degree centigrade difference.
Right.
And relative humidity is a measure of the vapor in air. So mold will grow where relative humidity goes above 85% for long periods of time.
Right.
The relative humidity is relative to air's capacity to hold moisture. So the warmer it is, the more moisture it can hold. Conversely, the colder it is, the less you can hold, until you get to 100% relative humidity, where it can't hold any more moisture and condensation comes out. Well, about 85% relative humidity, you start to get mold.
Right.
It's around 3 degrees centigrade above the dew point. The dew point is the temperature where condensation starts to form. So if we look at your phone, we'll see the dew point.
Right.
The dew point here is 12 degrees centigrade. So roughly speaking, at 15 degrees centigrade, mold will form,
Right.
and because of the temperature difference. And so that is actually in the sweet spot for mold at the moment as we speak.
Right. Okay.
So as a general rule, you want to keep the internal dew point. That dew point is quite high. So the two other properties I've been to today have had a dew point about 10 degrees centigrade or 9.
Right.
So it's 2 degrees centigrade higher, so you've got a lot more vapor. So dew point is also a measure of the amount of vapor in air.
Right.
And the general rule is you want to keep the dew point below the outside temperature
Right.
by increasing ventilation and or dehumidification.
Right.
And I see you don't have an extractor fan from the...
We don't have an external one.
You don't have an externally ducted extractor fan. So there are ways of mitigating it, but it's just sort of awareness.
Yeah.
And if I look in here, the temperature, see the temperature here it's going down to 9.8, so that's below the dew point.
Right.
So every time you open that door and there's a dew point that's greater in that room compared to this room, you're going to get condensation
Right.
forming here. I mean, it's a classic type of issue, and the three simple solutions and finding the right combination for you is three simple solution is remove the vapor, so ventilation, dehumidification, increase the heat, but then you can obviously put a radiator in here, but I wouldn't necessarily recommend that,
Right.
or put in insulation.
Right.
And I'll look at the insulation options, but I think that could well be something to consider.
Right.
I mean, I think you still need to get rid of the vapor, because you clearly got a vapor issue. But is it just these three areas here, or do you have elsewhere in the house?
I think nowhere else that we've noted.
Okay, I'm going to show you some simple solutions. So, preface everything I say on that you should increase the ventilation and dehumidification so as to reduce the dew point below the outside temperature. But if it's literally just those areas, you can just do everything with insulation, and relatively inexpensively.
Right.
Depending on what you want. So I've got different examples of different forms of insulation here. These are lots of different forms of insulation. So this is PIR, this is polyurethane insulation. It's plastic, it's non-breathable, so there are pros and cons, but it's relatively inexpensive. And you could literally just install sheets of that around the external wall, and that would and that's a very efficient form of insulation. So this is the standard insulation that most people are putting in houses nowadays.
Right.
There are lots of different sizes.
You would have to put that externally.
No,
right?
this you could do it internally.
You could do it internally.
I mean, you could potentially put it in, just sort of squeeze it in between the shelves.
Right.
So, and that will benefit this area as well, because
Yeah.
anything that's insulating the external wall there will
Help this.
help this.
Mm.
But you could equally put insulation on that, either on the other side of it, probably on the other side. So that's that, and that. This is relatively inexpensive. If you're a practical person, which I'm guessing you are, you could even do it yourself relatively inexpensively. I mean, you get a sheet costs about £55 for this thickness, which is 55 mil, 2.4 by 1.2. And you probably get a couple of sheets, but for that area there.
I mean, what we were thinking was that we were going to get all the plaster removed and replaster that, because
Okay.
it looked so horrible.
Well, if you want, okay, fair enough. Well, I mean, the insulation is going to hide that, but I'm starting off with the sort of the least expensive. So you can remove the plaster. You can put it on the plaster. You don't necessarily need to remove the plaster. Okay. And what you could do is you could just test out to see. So there are tables for looking at the thermal efficiency of it. So I'll show you the other ones, and then we'll discuss the merits of each one.
Yeah.
So these are sort of in terms of cheapness. So this is really cheap. It's great for simple cupboard insulation. It's not especially effective. It's called wood fibre insulation.
Right.
It's used for underfloor boarding.
Right.
It's overlay, timber overlay. That's wood fibre, and the good thing is that's vapor permeable, so it allows the transfer of vapor. You're on a solid floor there, so you don't have a timber to really worry about.
No, the solid floor, this half of the kitchen to there is wooden, and the other half is solid.
Ideally, you don't have PIR above a suspended timber floor.
Right.
Because otherwise you run a risk of condensation forming. It's called interstitial condensation, where it's forming within the wall, between the insulation and the wall itself, and then can drip onto the suspended timber floor and end up with rot, which could be a major issue. But this is Centapat, which is a German, it's a sort of lining paper with rubber. I'm not a huge fan of it, but I've used it in my own property, and I've gone off it just because it creases so much. It's really difficult to install. But there is a version of this called thermal lining paper, which Rock will make, and it gives you like a 1 or 2 degree extra temperature. It's quite inexpensive. It's very easy to install. And it's worth thinking about that, because that could be sufficient for your needs.
Yeah.
And that's relatively inexpensive. So a roll, like if you think of wallpaper, a roll of it would cost about £50 plus the paste and so on. So that's an option. This is the most expensive of them. It's called Space Therm. It's got this sort of fibrous, sort of like fleece type material, and then this is a type of plasterboard, and I probably wouldn't use it in that environment. I've used it a lot in my own property. So I was just saying that all the issues that you have here are vapor related, from excess vapor. You can take a number of approaches to them. Reducing the vapor, I think, is a good thing to do. So ideally, extractor fan, dehumidifier, but you could just simply use insulation, and that will. The only issue about insulation is it doesn't solve the problem. It's just reducing the effect, the localized effect of it, and you're getting it specifically there because you've got a doorway that opens onto the kitchen. You're getting the vapor from the unventilated hob and I'm guessing some internal drying of clothes maybe. You've got the washing machine.
The dryer's down in the basement.
Okay, so you got so that not that, but anyway, you're going to generate vapor here.
Yeah,
Roughly a quarter of a litre per person per day from cooking.
we do cook a lot. Cook every day. Yeah.
Do you do things like reducing sauces and soups and that sort of thing?
Yeah.
That produces a lot of vapor.
Yeah.
Obviously, whatever you're reducing is just becoming airborne and then finding its way. So as soon as you open this door, the vapor's going in here, and the wall itself the temperature of the wall is below what's called the dew point. The dew point is the temperature where the condensation takes place at. So it's like having a sort of permanent can of Coke from the fridge that you bring out in summertime and you get the condensation, and it's acting like that at the moment. And then because you've got a very thin bit of plasterboard between the kitchen and this original doorway is.
I think actually it might. I thought it was originally plasterboard, but I think it might just be ply.
Okay, well there you go, but it's not a wall.
No, it's not a wall.
So the wall would be across there. So it's poorly insulated between here and there, and that's why you're getting it specifically in the cupboard there. It's difficult for me to tell you why it started happening and getting worse, other than to say that a damp wall will take 6 to 9 months to dry out. So if it's constantly getting damp in winter, it may never have time to dry out, and a damp wall is a poor insulator, so you get increased heat loss from that. So that's my only that's my most likely suggestion as to why it's starting to happen now and not 41 years ago when you bought. But so insulation is definitely something to think about. Personally, I think every property should have a dehumidifier, a 20 litre per day dehumidifier. It will reduce your energy costs for a lot of different reasons, but a cold, humid property feels much colder than a cold, dry property. So you can turn down the thermostat and feel just as comfortable and not use as much heat that way. With a dehumidifier, it acts like an air source heat pump. As all the energy that goes into it comes out as heat, but you get 50% bonus because as you're going from vapor phase to liquid phase, you're releasing energy through enthalpy. So you get about a 50% bonus.
Have we still got a dehumidifier?
Yeah.
Okay.
We've got a sort of an industrial, a good sized humidifier, not a tiny one. It's
think about updating it, because the modern ones tend to be better, but I can't really speak for yours. You can test out the energy flow and the amount of vapor that it removes, but sort of a reasonable one will cost about £200. Miyako, DeLonghi, there are lots of different brands out there. It works in the same technology to a fridge, so if you're comfortable leaving a fridge on, even when you're away, you can leave a dehumidifier. If you go away much, or when you go away, it's good to leave a dehumidifier running, sitting on the sink with a little drain set to 70% relative humidity. And it's much more effective than leaving the heating on, which is what most people do.
We've got a son who still lives at home, so
it's rare that it's anyone.
It's rare that it's empty.
Okay.
Hardly ever empty.
So when it comes to mould spores are omnipresent, so they're everywhere in the world. But you'll get mould starting to grow above 85%, where the conditions are right, it will start to germinate. And once you start getting mould, the spores will increase the concentration of spores will increase, and so it will increase the risk of mold. So you sort of have to spray it down regularly, so like weekly, as soon as it. And I personally recommend HG anti-mold spray, but you know, there are plenty of brands out there, and the last place they said that they use vinegar, which, you know, I'm sure it's, but I don't think it's as powerful.
All sorts of things,
It does, but it's not as powerful as bleach. But you know, she had her reasons for not wanting to use it. But so I would do that. Somebody was asking about the little things for the little dehumidifier chemical sacks that you can get. I mean, it's going in the right direction, but they don't take much vapour out of the air, and you're better off dealing with the root cause. And obviously, while you've got, I mean, ideally you have an externally ducted extractor fan. As part of building regulations nowadays, since 2012, to have one. But and even when you come to sell the property, you know, you'll probably find that it is a recommendation to
I was just actually looking to see if we could possibly have one, because I don't know whether there's room there.
You could go up there. I mean, what above?
Yeah,
Oh, I would have thought this is a void here, isn't it? So you probably would do.
yeah.
But I'll have a look outside as well, see what's happening. So I'm looking outside and I can see that there is a small crack here, but I think it's probably superficial. But as water runs down, it can be absorbed, and small cracks can cause a lot of moisture to be absorbed through capillary action. And the vertical ones are less important than the horizontal ones, and also it's worse when it's a long a long section of wall, shall I say. Yeah, it doesn't look perfect, but I don't think that's your primary issue. So it's better where you don't have render. Oh, you've got a duct that's blocked up there. There's a certain so obviously mould is the primary visible issue. There's some brown staining here. So you'll get brown staining from two principal causes. One is from rust, and you can see there's rust there.
Yeah.
And obviously if there's condensation forming on this, it will rust and it will cause that brown stain to bleed through. You also get it from penetrating damp. So where the water goes through the brick, it will pick up pigmentation from the brick, and it will come through. And you have got a render crack on the outside. So I would say, anyway, as a matter of course, I would fill that crack. And you want to use, for thin cracks which you've got, is an external acrylic-based caulk. That just fill it. I think Polycell do one, but I mean you can find plenty. And then I would paint it, and paint it with an impermeable paint rather than a semi-permeable paint, which is what a lot of people do.
Yeah.
So Dulux and Zinsser do impermeable paints. So the reason that you want impermeable is the render's impermeable, and if you put a semi-permeable paint, then some of the moisture will be absorbed, and if you're hiding a crack, it can get through the crack and you're not aware of it. And so so there definitely is a potential for penetrating damp here. You can see condensation dribble marks there. Do you see that?
Yes.
That will come from condensation. And we know this is below the dew point, actually, as we're speaking. Which is thermal plasterboard, space therm, should I say. It's about £80 a sheet. That's only a quarter of the normal size, so it's about 2.4 by 60, so you probably need, I don't know, just top of my head, possibly 10 sheets there.
Right.
So it's starting to become relatively expensive, and
yeah.
then getting somebody to install it is relatively expensive. This doesn't look so pretty, but it would be a much cheaper way of doing it.
Yeah.
And this is vapor permeable. The third one that's vapor permeable, maybe the one to go for, is the thermal lining paper, rock wool. And that, as I say, it will give you another 2 degrees centigrade. It's not going to solve all the problems, but it will go a long way to solving it. And then it will allow the wool to dry out. You could use a combination. So I often use a hybrid approach. So you could, for instance, use both this relatively inexpensive, so you can buy it's like B&Q, £25 for 20 sort of sheets about a metre by a metre, something like that. So you know, and then you could adhere those to the walls and put on thermal lining paper, which then would be easier to paint and look, you know, in keeping, I would say. So that may be the option to go for, and it's something that you could probably do yourself.
Yeah.
I mean, I don't know how handy.
Yeah, I can.
But that would solve this problem. So that's probably, so what you could do is just get a little sample and just test it out and just see. Well, you may have to actually buy the real thing. So one of the issues, you've got metal, and the metal is going to conduct the heat, and it's very difficult to insulate around that. But if you just put it in between, then you'll certainly reduce the amount of heat loss dramatically. Or you could take the insulation off and screw it onto the wall. Actually, I suppose you could do that. Take all of these off, and then if you know exactly where the screw hole is, or just leave a pilot, you could screw it back in with the insulation behind it. That may be the thing to do.
Have to go out now. I think you'd Roger.
Actually, there is or was an extractor fan.
Oh, I
there,
saw.
but
Yes,
it doesn't work.
Up.
It doesn't work. It's blocked up. Would it be a good idea to get that reinstated?
I suppose yes, or no, maybe no, actually, because the thing is that it would be pulling in air from everywhere, including the kitchen, and that's where the humidity is in the kitchen. I mean, it's good to have it from smell perspective, but I suppose you've got this window, haven't you? No, I probably wouldn't do. I probably would block it up, because what it does is when it's open, well, it's not fully open, but it's partially open on the outside, you're going to get some heat loss in there. You get heat loss around the tank, so the cistern, as when water pours in, it's coming in at a low temperature, and then so you often get sort of condensation around there. I think I would probably insulate this room in the same way as the other one. I mean, one thing to say is that tiling doesn't deal with the problem, but it hides it. And you can get anti-condensation, anti-mold paints that are relatively effective, but they're not everything. So that's one thing to consider. But yeah, thermal lining paper would be a simple solution, but it's not dealing with the root cause, and the root cause is the excess vapor.
Right.
There's a bit of dampness in the cellar here, but cellars, it's going to be very difficult to
Mind your head on that beam.
And you've got no real ventilation that I can see.
No, there isn't.
And it's presumably it isn't heated. The dryer itself will produce some heat when it's on.
Some of the central heating pipes run through here,
so it warms it up. But then
that's hot at the moment.
But when it's not when it's not on, you presumably also have the cold water running through here. But I mean, I can't. So most cellars have some degree of dampness because the original purpose was for the rainwater to percolate down through the earth and then evaporate out and then go through subfloor vents.
Right.
So when you block up those subfloor vents, you increase the risk of having a leak going undetected or rainwater. But I don't see any specific issue there. Airflow, putting in extractor fan there. The only thing about an extractor fan is in our humid climate in London, the outside air is going to be close to 100% relative humidity when it rains, and you'll find that the outside air is pretty saturated most of the time. So if you're just dealing with ventilation, you'll end up above the 85% for large times of the year. So ventilation in itself isn't sufficient, and insulation is only insulating against the external air, but temperature, if you're not getting heat from the inside, you're not warming up on the inside. But I'm guessing you will get a certain amount of heat through because this window will let heat in and you're going in and out. There's and then dehumidification and airflow. I think those are surface. So surface is something to consider. So some surfaces are more prone to mold than other surfaces. Right. That's because mold actually needs oxygen, high humidity, and a food source. And certain paints will trap dust that the mold will feed off better than other paints. So you can use anti-mold paint, which is less prone to absorb the dust, but it's not 100% perfect. So that can go some way. And then obviously using anti-mold sprays regularly is another solution. Should we have a look upstairs? Are there vapor sources upstairs? So you've got bathroom upstairs, I see.
Yes.
What I'm seeing is obviously no ventilation in the bathroom, and you open the window, which is great, but what a lot of people will do is also keep the door open. It's a sliding door, which means that it's liable to stay open quite a lot. It's better to have it closed and the window open, so that the vapor's going out rather than back into the house. So I would try, what I'm going to do is at the end I'll give you 3 things that I want you to try and do to reduce the amount of vapour in the property. I'd say that's one of them. The other one will be cooking with tops on pots and pans.
We do that religiously. I mean, saving energy where possible, we always put lids on pots. I suppose it might be possible to put a vent, an extractor fan in there.
Personally, I think it's better putting it through the wall.
Right.
You can put it through there, but then you're going to lose some of the double glazing. I don't think it. I mean, from an expense point of view, it's much cheaper to do it through the wall anyway.
Really? Mm-hmm.
Well, because it's you need a dumb tip drill. It takes about half an hour to do it. But,
right.
I would do that. You're going to use the data loggers to identify where your key sources of vapour are. Right. So you'll see there'll be increase in vapour at different times of day. For now, keep the data loggers where they are, but in the future you can move them around and you can put one in the bathroom and find out whether that's a contributory factor. There's some fluctuation. Do you see how it's 54, 57 and 59? The temperatures are pretty much...
humidity,
but then the same environment, so you'd expect them to be the same. I'm showing 56 on this. So I'm going to basically adjust them to this, and then they'll be calibrated. So they're pretty much in line with each other. Do you see the dew point? the dew point, we're going to be looking at the dew point differential. Dew point is a measure of the amount of vapour in air. It's also the temperature where condensation takes place at. So we'll see some degree, you see the kPa, which is the pressure, partial vapour pressure, and they're all aligned. So what I'm going to get you to do is press the, I normally say green numbers, but they're not showing as green. If you press the black number there in the centre, yeah, that then synchronises with it, and it's drawing the data down. So the data is held on the loggers itself,
Right.
not on the phone. I've calibrated it so it'll bring in the correct numbers now, and then I'll get you to send it to me. And what I'll do is I'll ask you to send me an update, not this weekend but next weekend, and then I can look at all the different properties I've been to, and you can compare and contrast. But it is relatively high. See this 12 degrees centigrade. You know, the outside temperature is probably about 4 degrees centigrade. So if in a well ventilated property, the outside dew point is likely to be 4 as well, because that's the temperature, or you know, it's raining outside, so it's likely to have an almost identical dew point. So if you press the calculator sign, top right.
This?
Yeah. And export sign, top right. And export CSV. And then, have you got a Hotmail?
I've got Gmail.
Gmail. And then I just send it to myself. Yes. Well, actually, it's on there.
There.
Actually, if you can put the postcode, it'd be useful.
Where do you want me to?
In the subject line. There's that one there. That one there. So I'm looking at 3 different things. I'm looking at the surface relative humidity. So that's the relative humidity on the surface, taking into account the temperature of the surface. Second thing, I'm looking at the dew point differential. So that's the difference in dew point between one data logger and another one.
Yeah.
And that tells you whether vapor's been generated or removed, and it will give you a lot of information within the same property. And then the third one is looking at the comparison between the internal dew point and the external temperature. And as I say, you want to keep the internal dew point below the outside temperature by removing vapour. There's a big myth about rising damp.
Okay.
Rising damp comes from groundwater.
Yeah.
That's the water under the water table. In London, groundwater is pumped out from Stevenage through to Croydon and beyond. Historically, it was pumped out for industrial purposes. Nowadays, it's just pumped out to stop car parks flooding, or the underground network, or whatever. So it is basically impossible in London. You can get areas that look like rising damp. So rising damp is the rise of moisture from groundwater. And what's the reason that that's important? So every form of water will rise. It spreads through capillary action in all directions. It's absorbed, whether it's penetrating damp coming through the wall or whatever. But the difference with rising damp or groundwater is that you can't easily get rid of groundwater on an individual property basis. Right. You can get if your drain is cracked, then you can end up with something that looks like rising damp, but it's a cracked drain, and you need to solve your cracked drain. Otherwise, you could end up with subsidence or horrors that are much.
No, well, the only reason I asked is that in the previous house we had, when we sold it, the people had a survey and they said we'd got rising damp, and so we had a silicone injection into the brickwork before they'd buy the property.
A majority of damp houses have had rising damp treatment.
Right.
but it's a misunderstanding. It's,
Right.
it's a whole industry that's based on a misunderstanding about rising damp.
Right.
Actually, I'm seeing that this has been replaced, hasn't it? You've got a new plaster up to this level.
Yeah, it's
Plasterboard. It's dry lined, is it? So dry lining is where you put plasterboard up against timber battens normally.
yeah, I think so. Yeah.
Yeah.
Again, this has been like that forever. I mean, that's the chimney. The old chimney. There was a solid fuel boiler there originally. Not in our lifetime, but originally it was.
So what? Let's say you did have high levels of groundwater. You would have flooding in the garden. It would be obvious.
Right.
But the whole property would be affected. It wouldn't
Right.
be just the back.
No.
It would be equally everywhere. It looks like flooding essentially.
Right.
And anyway, these properties are normally built with damp-proof courses, which reduces the risk.
I don't know whether they would use in 1900. Were they putting damp courses in? Or?
They did. It was 1875.
Right.
They started doing it, but it was largely because of changes in design, because of the drainage that came in, the basalt jet and the bringing toilets indoors.
Right. Yeah.
Rather than against rising damp per
Right,
se.
okay.
I mean, I've got a property that doesn't have damp-proof course in it, and it's fine. I mean, it's a long story because it was actually damp-proofed at one stage, which is counterproductive. It's counterproductive. You'll find a lot of the properties I do surveys have had damp-proofing.
Yeah.
It reduces the temperature of the wall because you're using plaster that's not as absorbent, so you don't have all the little air pockets, so it's not as good an insulator.
Right.
So there are a lot of reasons not to have
Not
rising.
to do it. Right.
It certainly wouldn't get rid of your problem.
No.
I mean, arguably it would make it worse, but this is a damp meter. This is a standard damp meter, and so that's dry there. And that's down there.
Oh yeah,
as you would
quite
expect.
a difference.
Quite a difference. So despite the condensation dribble marks, it's dry there.
That's certainly a hot spot, isn't it?
Well,
Just there.
that is actually where the crack is outside.
Right. So there's a logical explanation.
So there's a good chance that, but there's more there. In the corners, you get a lot of heat loss because it's got extra surface area on the outside, so you're more liable. So these are. I'll show you a different type. It's called a Dr. Damp meter, and it'll give you. You can sometimes you have to get it flat, but it's quite a good thing to do. Is just put it in the same place, sort of once a week, and just take a note of the number.
And you can see whether it's drying or getting wetter.
You can see the trend. You'll find that it takes, so it is to an extent of exactly how much you press on the wall and so on. But so you'll get ups and downs that have nothing to do with the wall itself. But if the trend is in the right direction and you don't want to do it too often because
it'll drive you mad.
It'll drive you mad. Once a week, once a month, just to know that you're going in the right direction. But yeah, so and you have to make sure to put it on the second one, which is masonry. You've got dry line, so this is, I think it says dry wall, dry line, and then you have got the potential for this surface. So you have to put it onto. It says wood and then building, and then this gives a. But this is just surface. Right. So in this case, actually, the surface is dry. Oh, there you go. It's a bit damper there. But this is conductance, so it's across. It's actually what it's measuring is actually salts, the electronics transfer ions.
Yeah. Okay.
Water, it's pure water. Wouldn't actually conduct.
No.
It's all the the thing's in water.
Dissolved in it. Yeah.
Before, but so these cracks
sort of tiny cracks. Yeah.
so horizontal crack, it can absorb more water because it's coming down.
Right.
But this section of wall is actually a fairly short section of wall. So if you're looking at a long wall like that, you can get a big build-up of water. So towards the end, you'll get a lot. But actually, it is fairly protected by this. I mean, obviously, you've got water coming at this direction. So these thin cracks, it's difficult to know whether it's going the whole way through the render through to the brickwork, but it can absorb quite a lot. A thin crack acts like a capillary, and
it sort of
sucks it in. So I've been to properties where you can see it's glistening with water above and then completely dry underneath, and that's because all of that water's been sucked in.
Yeah.
So you've got these cracks here, and so this bit here, the paint could well be covering a crack, and it could be semi-absorbent paint. So it is potential for you to have penetrating damp there.
So we need to address the cracks and then paint it with a special
Yes.
paint to keep the moisture out.
Yes, so you use, it's a mistake a lot of people, including builders, make, is to put, weather shield and paints like that, if you look on the tin, it says it's semi-permeable, so it will allow vapor in and out, but the render itself is impermeable, so you should really have an impermeable paint on an impermeable, because otherwise you can hide a defect. I mean, obviously if you're just painting semi-permeable onto an uncracked section of
There's another crack there at the bottom.
yes,
You see it
coming
up.
And then ideally,
Oh, and look, there's the rendering's coming off there.
but that's probably rendered. It's probably just the paint that's probably it's difficult to know. But at the base of the wall, you'll also get water that can get in through the render. So ideally, there's a fillet of cement across there. But I would still maintain that your primary issue is internal vapor, because the internal dew point is above the wall temperature.
Not so many cracks.
It's not so bad here.
No, it doesn't, does it?
Yeah. There can be a lot of different reasons for that, but putting replacing the window might have changed it.
Yeah.
To conclude, you definitely have an excess vapor issue. That I know that because the internal dew point of this area here is greater than the temperature in that room there. It's greater than the outside, but it's also greater than that room there. And the temperature of the room there's probably somewhere halfway between the internal and external temperature. You could simply and so just to step back a bit, you don't have the ventilation. You have a dehumidifier. No, you don't. You don't.
We do have one.
You do have. You got an old one. That's it. Yeah. But you're obviously not using it now. But you could try that and just see how successful it is. But do consider getting a modern one, just because I think the effectiveness should be much greater. Yeah. There's been improvements, and I think all properties should have one. I always leave, whenever going away, I always leave a property with
my son, who lives in Croydon, had a damp problem in his flat, and he's got one of those mini dehumidifiers, which he runs constantly.
Okay, I personally recommend a 20 litre capacity. It's a sort of sweet spot between not being too heavy and cumbersome and noisy and being effective.
Oh, his is almost silent.
Okay, well, if it does the job, it does the job, so that's good. So we know you've got excess vapour and there's mould, and you'll get mould because of that. Insulation is a solution. It's not solving the root cause, but it will go a long way to solving the mould. But because you appear to have water coming in from the render crack, which I think you need to deal with, and the wall is damp, but it's damp deep within. It's less the surface, it's actually deep within the wall. You really should have a vapor permeable insulation. such as the wood fibre, the thermal lining paper, or a combination of the two. And in both the bathroom and this room, and think about the insulation behind this cupboard here. You might put a bit of additional insulation in.
You think that additional information would cure the problem there?
Yes. So insulation.
I mean, because that door is more or less always closed. I mean,
I know, but you're getting heat loss there.
Yeah, through there.
Because this is. Did you have somebody at the door? Is it?
No, I think that was my phone just getting a message or something.
So your bathroom, you don't have an extractor fan on your bathroom, and the door is a sliding door, so less likely to be closed, and it should really be closed with the window open to dry it out. Cookware tops and pots and pans, which you're doing already. Drying clothes downstairs with a tumble dryer that's condensing tumble dryer should be effective. I can't see any effects of that, but tumble dryers, those condensing, at least the older ones, the heat pumps are better, but the old condensing tumble dryers do release quite a lot of vapour. But there are no, I mean, there's some dampness there, but not major.
No.
So drying clothes on towels on radiators, which we all do, you know, that could be a source. So the three things that ideally should do in the short term is get the dehumidifier out that you've got and get that running. Measure the dew point, internal dew point, and try and drive it down with a dehumidifier. And ventilation. You've got to remember that when you ventilate, when you blow air out, you're replacing it with air from the outside, which can never have a dew point above the outside temperature. So if you're constantly blowing air, you always bring the dew point down to the outside temperature. When it's raining, the outside dew point is the outside temperature, because rain is condensation.
Right.
And then the third one is short. I'm just trying to think in short term. Bathroom door. Keep the bathroom door closed. And the. I mean, you won't get so much vapor from the bathroom, but it's all accumulative.
Yeah. Just a silly question, but would it be an advantage to keep this door open rather than closed? No, it wouldn't make any difference.
No, because you've got no heating there, and
no, but the heat would sort of permeate from here, wouldn't it?
But you get the vapour as well.
Right. Okay.
I would say not until you have either heating or insulation there, or you're bringing the internal dew point down.
Right. Okay.
But no.
Yeah.
Because. Yeah, so
I can certainly start the dehumidifier this afternoon.
So the general rule with the dehumidifier is you put it in the place where you're getting the highest dew point, or because you get the most water coming out then, or the place where you've got. Oh, I know the extra one I'll give you to do is to put a fan, just to blow the air around in this area.
Oh.
Have you got a fan? Have you got like a?
Yeah.
I mean, obviously, a heater function is better, but without a heater function, at least it's blowing the air around.
That might help the dehumidifier as well.
It would definitely help the dehumidifier. I'd either place the dehumidifier here or there, but I would possibly put it here with a fan, and that will go a long way. So when you're thinking about putting the foods back in, try not to put the tins next to the coldest walls, or so not into the corner.
Right.
And I mean, ideally, more of the tins would be on this side.
Right. Okay.
Because of the way they'll absorb the cold, or they'll release the heat and stay cold for longer than air. Right. Also use an anti-mold spray like HG anti-mold or bleach. And also, so that's I gave you the three short term, but the longer term ones, are to put the acrylic caulk in, ideally paint the external brickwork. I would put vapor permeable insulation in,
Yeah.
and then longer term think about ventilation.
Right.
But I mean, you know, that's
Let's see if I can get someone to put an extractor fan that's
Yeah.
vented to the outside.
yeah.
I don't know how difficult that would be.
I would say it will take somebody about, I mean, in physical work terms, it's probably only about an hour or 2 hours of work, but trouble is getting anyone to do anything that takes less than a day. And I mean, ideally, so this type of extractor fan can normally do both. You normally have a little switch inside here, and it can either go out through here.
Yeah, I think this has passed its sell-by date anyway.
Okay,
So
well, a new one.
I'm just thinking of how it would be vented.
Well, you have a hidden thing through here, which is probably goes through above the ceiling next door, and you can. I imagine. So if I look at the ceiling height,
above the
well, within the ceiling void, it
Yeah.
seems to me as though that
all
is
right, so it would be up.
above.
It would be somewhere above here,
Yeah,
and then would go
straight
at right
out.
angles.
Yeah, or
Or
that way.
or
It's
even
probably
straight.
just as easy to, because then you could feed it through. You could just have, and ideally you have a rigid tube rather than a flexible ducting, because
Yeah.
you get much better through flow with a rigid tube.
And what sort of professional would do that? I mean, do you need a
Electricians
builder or an
normally
electrician? An electrician would do
Yeah, they tend to be more expensive, but they're the ones that tend to put in bends.
it. Okay.
Because they need to wire up the extractor,
Yeah.
but they would also be able to do that.
We've got a firm of electricians that we use from time to time, and they're quite good. I might ask them to come and give me a quote for doing that.
Yeah. And so, as a general rule, go for a quiet fan that people use
Yeah.
rather than a fast fan that's
Yeah.
noisy and no one ever uses, because
Yeah.
and make sure there's one that's easily accessible buttons
Right.
rather than fiddly and
Yeah,
hidden and so
okay.
on. I would definitely have an over hob variety of fan rather than a fan that goes through the wall, which is called an adjacent fan, because it's much more effective when it's just above the food.
So, well, I mean, where that is.
Where that is,
Where,
yeah.
so,
Yeah.
yeah. I mean, I think that's what I'd do. I'd replace that with.
But you may be, an electrician may say to you, oh, it's much easier to put it through that. Well, yes, but it's much less effective.
Right.